Okay, good morning everyone. Welcome and thanks for coming out to this early session. Wanted to start off by just kind of summarizing what the talk's going to be about and make sure I set expectations. That title could mean any number of things to any number of different people. So I want to make sure, a lot of people don't take the time to read the description and really figure out what it's about. So let me just set the stage. If what I say is not what you were expecting, please feel free to, find a session that's better suited for you. But the idea here is that when you go to build Windows Store applications and your focus is for a line of business or just business in general, and I'll kind of clarify what I mean by that as we get into the slides, there's a specific set of concerns that should be sort of forefront in your mind. And those are things like maintainability and testability. Not necessarily, certainly time to market is important, as it would be for a guy, putting an app together in his spare time and trying to get it out in the Windows Store. But the focus here is that when it's something that's there to support a business, to support its products, services, its end goals as a business, then there's a little more diligence that goes into building that app, or should, to write a good maintainable app that can evolve over time, add new features, serve its users' needs, and that's kind of the focus of this. Now, as a means to that end, there is guidance put out by the Microsoft Patterns and Practices group that was originally codenamed Kona. So if you did read the description of the talk, you saw that mentioned in there. It was called Project Kona when it was in development. It's now released, and it's called Prism for Windows Runtime. So the primary focus of this is going to be the overarching goals of maintainability and testability and building a good structured app and really understanding how to integrate with WinRT features. But the means to that end is to leverage the Prism code from Microsoft Patterns and Practices to do that. All right, so with that in mind, a little background on myself. My name is Brian Noyes. I'm from a company called Alliance. We do end-to-end project development, architecture as a service, consulting, training, that kind of thing. I'm also a Microsoft Regional Director for the Mid-Atlantic region. That's basically Washington, D.C. and the surrounding states. That program, if you haven't heard of it, it's fairly small. It's about 130 of us worldwide, selected people by Microsoft in given regions, somewhat similar to the MVP program. We evangelize their products. We give feedback to the product teams. The only main difference is we have a little bit more direct pipeline to the senior management at Microsoft to give them feedback of how we think they're doing. Also a Microsoft MVP. A Pluralsight author, and direct relevancy to this session. When we're done here, I will set some cards up here on the deck. I've got a Pluralsight course that I just released about a month ago now that is basically a 6-hour version of what you're going to get here today. So if you want the expanded version to know all about Prism and all the depths and how to use it, I'd recommend you check out that Pluralsight course. So the cards I'm going to put up here, just out of curiosity, how many people here are Pluralsight subscribers? Pretty good number. So those that aren't, you can grab one of these cards. It's a free 1-month pass. If I run out of cards, don't sweat it. So don't race the stage here. They've got plenty of them out at the Pluralsight booth in the expo hall, so you can grab them there as well. So it's a 1-month free pass to go watch as much of the course content as you want, and there's about 500 courses in the catalog at this point. I'm also part of a bunch of different insider groups. The thing that's most relevant to this talk is I was actually part of the Prism team, so I worked as a vendor for the Microsoft Patterns and Practices guys on this Prism, and I'll explain there's a previous Prism. So another show of hands here, get you guys wake up with some exercise. How many people have heard of Prism before for WPF or Silverlight? Good number of you. And how many of you are WPF or Silverlight developers? Good number, okay. And how many are completely brand new to Windows Store apps, haven't written a line of code? Okay, somewhere around half of you. Okay, good. So I worked directly on the team, was involved in the requirements, the design, and even wrote some of the code that's in the shipping Prism stuff. So I know this stuff pretty well. The other important stuff here is my contact info. We've got a good-sized crowd here. If you do have questions, with the bright lights, sometimes it's hard to see. Try to grab my attention. I'll try to remember to repeat back the questions. And then if we don't get it answered during the talk, come on up afterwards, and we'll do the Q&A at the end there. All right. So with that, basically what we're going to go through is a little bit of, I don't have a separate bullet for it, but a little bit more on the business context of the talk, and then we'll get into what Prism for Windows Runtime is and how it helps you to solve those problems. We'll talk about structuring your app with MVVM. Part of the maintainability focus is that you should have separation and concerns and think about things as a layered architecture, even on the client side. And the most common way of doing that in a XAML application is to use the MVVM pattern. Another thing I meant to clarify up front is that this guidance that I'm going to be focusing on here is all about the XAML side of Windows Store apps. So are there Win.js guys in here? Okay, good. One. Okay, so unfortunately, the stuff I'm going to be covering here is not really applicable to the HTML5 Win.js side of the world, nor is it directly applicable if you're a C++ XAML developer, because that compiles to unmanaged code, and you can't take references to these .NET libraries that are going to do a lot of the stuff I'm showing here. So if based on that it's not relevant to be here, please feel free to jump off to another session there. So I'll go through, what is Prism? I'll talk about how Prism helps you with implementing the MVVM pattern and what it looks like to structure your Windows Store code that way. Then we'll look at navigation and state management, and we'll talk about the fundamental concepts there from a WinRT perspective, but we'll also talk about how Prism facilitates those things and makes it so you can put the code that supports navigation and state management in the right place in your application, which in an MVVM context means in the view model itself, not in the code behind the pages. Then at the end, we'll talk about validation, which is something that for a business app is obviously pretty important. Most of the samples out there and all the demos you see of Windows Store, it's all content consumption, right? It's news, weather, data on the screen in some form, but it's all just reading data. And certainly when you get into the business context, inputting data starts to become kind of important. And you don't see a lot of samples of that. So one of the things we focused on in the Prism stuff is data input and saying, okay, as soon as you have data input, validating that data is important. And then you go and you look at the WinRT platform and you realize there is no validation support there whatsoever. So one of the things we did in Prism is gave you some data input validation mechanisms I'll demonstrate at the end. So that's the overall game plan. Let's talk a little bit about the business context here, just to make clear some of the terminology. So line of business is in the title of the talk, and line of business was our primary focus in setting out to do the Prism guidance. Is basically saying, okay, there's a certain set of problems a business app developer is going to face in trying to move to the Windows Store and trying to build WinRT applications. We tried to identify what are those problems and how would they go about solving those on their own. And then where the Prism guidance comes in is it is guidance. They call it guidance because it's a mix of reusable code, samples, and documentation to help lead you down this path. So we tried to identify first, who's our target audience and what are the kinds of problems they're going to solve. And one of the things, we try to clarify in there is that there's really two kinds of business apps that are important here in the Windows Store arena. There's business to consumer, or B2C, which is really a more common form of business app at this point. Things like anything from movie services such as we have Netflix and Hulu in the U.S. I guess those aren't viewable over here in Europe for the most part. But you've got those are forms of business to consumer. You've got product sales type of applications. Electronic stores and stuff can have their own app out there to help sell their products and things like that. So that's more the business to consumer, where the end user, the big distinction here between that and true line of business is who are the users and what machines are they using the app on. So a true line of business app, in most people's definition, means it's somebody's job to use that application, and they're probably using that application on a machine provided by the company. And so the company has more control over that machine. They may, lock it down tightly and not let it leave the premises, and the users have to go in there and it's their job to sit there and use it all day. It could be someone who has an app that is a part of their job function. They have to go maybe take inventory in a warehouse, or they have to call up customers and do some customer resource management type stuff. But it may not be their entire job to use that application. But those would all fit in that line of business realm. But most of what you see, in the store, especially the true Windows Store, is business to consumer apps because they're out there for anyone to grab. Now, this gets down to some of the weird terminology we have to deal with at this point, because Microsoft will refer to these always as Windows Store apps, even if you're in the line of business category. And if you're not aware, when you're in the line of business category, you don't have to go into the Windows Store. In fact, a large percentage of true line of business apps probably will never go into the Windows Store, but they'll still be referred to as Windows Store apps. The way you get them onto a machine is a technique called side loading. You have a couple of options for that at the current time, where there's a PowerShell script you can run basically if you have direct access to the machine, that you can basically do an install of sorts through PowerShell. Or there's a product called Intune that lets you do you basically can set up your own local store or enterprise store, if you will, and have the apps installed from there. So there's a couple of options you have for the line of business arena to get the apps onto the machine, and they're still going to be called Windows Store apps as far as the technology is concerned, and a search buzz phrase, if you will, and even where you start in Visual Studio is File, New Project, Windows Store app. But, from a true perspective, they may never go in the Windows Store. So you have to kind of reconcile that in your mind in terms of the terminology. Now, where you go to get this Prism for Windows runtime stuff, let me just switch over here to my demo machine. And got to unlock the screen. Sorry about that. Okay, so where you want to go is Prism Windows Runtime. Just spell it out all one word, .codeplex.com. That's the main landing site for the Prism guidance. On the page here, there's a couple of separate links because the way this code ships is it goes out as part of the Windows SDK samples, or at least a portion of the code does. So there's a couple of links here. There's the big attractive download link over here, but that's not the bulk of the Prism guidance. The bulk of the Prism guidance, you have to find this tiny little link that says code down in here, and that takes you over to the SDK samples page where the main part of the code resides. So it's a little fragmented right now in terms of how you get there. The downloads here on the CodePlex site are just the quick starts. Some sample apps that I'll be using some of those in the demos today. So you'll want to get both pieces there. The main thing from the little link and the quick starts from the big downloads link there. All right. So what's in the box, if you will? If you go and grab this Prism stuff and start trying to figure it out and see what it can do for you, the main thing I'm going to be demoing shortly is there's this big end-to-end sample application called the AdventureWorks Shopper. And this was basically the way we approach this is, good frameworks are not built, they're grown or extracted from existing code. That's kind of how we went about building the Prism guidance, is we built an app and we set out, we followed team practices as if we were a company building an app, focusing on the right things, and doing everything we needed to do to get it into the store. And in fact, this app, even though it's not in the store, it went through the full process as if it went in the store, and it even went through some additional rigor because of the fact that it's in the SDK samples. They have a process of Microsoft where if it's something called a first-party app, an app released by Microsoft, such as the built-in news app, mail app, and those kind of things, they have to go through an additional approval process. So we even went through that to make sure it, is to the letter of the law of the guidance of what Microsoft thinks you should do for a Windows Store app. So I'll demonstrate that shortly to show you where some of the functionality is and where the capabilities of Prism come out in that application. Then there's the quick starts I just mentioned. There's 4 of those, really. There's 2 variants of a Hello World one. I'll be showing some of that code here in the demos. The validation one I'll be using for my demos. There's also one for PubSub events, which is a loosely coupled event mechanism. Just for scope reasons, I've got a lot to cover here. I'm not going to go in depth on that, but I'll point you to some resources where you can read up on that. Obviously, there's documentation. This is, not read it end-to-end kind of documentation book style. But it's got some really good lessons learned in there, because through this whole process, we were kind of figuring things out as we went too, much like you would have to do on your own, where we look at the guidance of what do they say you're supposed to do for a Windows Store app, and then we look at, what would we have done as traditional line of business developers on WPF or Silverlight, and then we try to morph that into doing it the right way on the WinRT platform. So the documentation tries to capture a lot of those decision process where we're like, well, we would have done it this way, but we chose to do it this way on WinRT because this is what the design guidance says, and this is how we interpreted that design guidance. So there's some pretty useful kind of lessons learned there in the documentation. The bulk of what's going to be important to you if you go and use this stuff is the reusable code that comes out of Prism. So there's 2 reusable libraries in the form of Windows Store app class libraries. So these are not portable class libraries. Well, I take it back. The bottom one is a portable class library. I'll get to that. But the main one here, called the Prism Store Apps Library, is just a Windows Store class library. So it's only usable with WinRT applications, and specifically .NET Windows WinRT applications, not the WinJS type. The key features that we have implemented in the box there is structuring for the MVVM. So we have base classes for views, view models, and your application. Navigation support and state management that I'll get into, where we have basically some wrappers around the way navigation happens in the WinRT platform so that you can manage that from inside of your view models. And likewise with the state management, your state is generally going to be in your view models, so we have wrappers so that you can manage that from your view models, and you'll see that in the demos. We've got commands. Anytime you're doing the MVVM pattern, you generally need commands to hook up when things happen in the view to trigger logic in the view model. We basically ported over, for those who raise their hands as being exposed to Prism in WPF or Silverlight, we ported over the delegate command from Prism 4 to the WinRT platform. The validation was all kind of homegrown code following patterns that were established in WPF and Silverlight for the way validation happens, the kind of presentation you want for validation. But as I mentioned, the hard thing here is WinRT itself has no support for this. So for the WPF and Silverlight people in the room who had exposure to validation on those platforms, you know that bindings had built-in validation and the controls themselves had built-in display of validation errors. None of that exists in WinRT at the current time. Maybe today at Build they'll be announcing new stuff. I don't even know. I'll be watching to see if they've done anything in that arena. But in the meantime, what we did in Prism is built up an infrastructure so that you can do normal input validation in a way that feels similar to what you would have done in WPF or Silverlight. The search, settings, charm, and flyout stuff is that those are some specific features of WinRT that there is WinRT APIs for doing these things, but they all are very kind of page-centric. They expect that you're going to do everything from your code behind in your page, which goes directly against the MVVM pattern. So what we have here in terms of those features is wrapper code, basically to make it so you can control and command that stuff from your view models, but not be coupled to the WinRT APIs in your view models for testability reasons. And then the last one here, the PubSub events, that one is a portable class library, and for the people with past Prism experience, that is basically a port of the event aggregator, as it's called, is the pattern it's based on. It's the event aggregator code from Prism 4 ported over to WinRT, but not just to WinRT. Basically, we did it right this time. I fought for this back in the early Prism days and lost. But there's one piece of coupling that was always in that feature set in Prism before, was some thread dispatching capabilities. And the way it was done before was in WPF, we took a direct coupling on the WPF dispatcher. In Silverlight, we took a direct coupling on the Silverlight dispatcher. If you're familiar with async in .NET at a lower level, there's a thing called a synchronization context that those are all based on. So this time we did it smarter. We dropped down to the synchronization context level, which is a standard API for Silverlight, WPF, really full .NET framework, Windows Phone, and even like Silverlight for Xbox. Any of the Microsoft platforms have that concept of a synchronization context. So we turn this into a PCL where you can target any of those things. But definitely WinRT is one of those targets. All right, so let me give you a quick tour of the AdventureWorks Shopper sample so you can see where some of these features come into play. So I'm going to fire up the main sample app here. First off, before I fire it up, just you can see from a code structuring perspective, we've got, sorry, let me take a drink. We've got a main Windows Store app called the AdventureWorks Shopper. We chose for testability reasons to break out everything other than the view part of it, if you will, all the logic, including view models, client-side services, model objects, and all that, into a separate class library called UI Logic. Excuse me. And then we have some backing web services that you'll see when it starts up. It's dealing with product data. This is more of a business to consumer sample because that's more approachable for people than some specific line of business scenario. And then the two reusable libraries down here. So let me go ahead and fire this up. And you'll see it starts up, standard splash screen. You saw a quick little spinner there because it is doing asynchronous loading of data via services. We use web APIs, ASP.NET Web API for these services. And part of the mentality there was, we could have used WCF. You can certainly consume WCF services from Windows Store apps. But as you start getting into the Windows Store app arena, especially if you're focusing on mobile form factors like tablets, there's a pretty good chance you're going to want to build it for other platforms as well, such as Android and iOS. And as soon as you do, it's much easier to consume those kind of services on those kind of platforms as Web API services instead of WCF services. So that's why we chose to use ASP.NET Web API. Now you can see the scenario is a product shopping catalog type of thing. We've got different top-level categories here. So some of the things demonstrated in here is the navigational aspects, that we have multi-level hierarchy of navigation here. Tomorrow I have a talk at 10:15 where I'll dive into navigation more deeply. I'll show you some of the basic APIs that Prism uses here today. But if you want a more comprehensive coverage of how navigation works in Windows Store apps, come to that session tomorrow. But you can see we can go down one level and we see different subcategories of bikes. We can go down one more level. We see a collection of all the mountain bikes in this case, and then we can go to the lowest level, which are the detail views, and see the information for an individual product. Now, you can also find things through search. And you see that we're using the standard search charm here that's integrated with the operating system. The app shows up in the list of applications that support the search charm. So you can actually, even if you're in the news app, let's say, you could fire up the search charm and then click on that and it would activate the application. And then you can run a search for a product. So we'll say a lock here. And you can see the experience happens within the application for displaying the results, but the presentation of the search experience is done by the operating system itself. So that's the search contract or charm there. When we get down to an individual product detail, we can add it to our cart. You see in the upper right corner here, there's a little shopping cart icon that increased its count there. It's really more than an icon. It's a view with a backing view model that talks to services and maintains the overall state of the shopping cart for the whole application. Now, it's a very simple view. It's a single button in that view, but it was more that there was, enough logic there supporting that button and the presentation in that button that we chose to factor that out as a separate view model. It's a little bit contrived, to be honest. It was an opportunity to show how to compose child views and view models within a parent view and how to communicate between those two. So those pub/sub events I was talking about, that's really what's involved here when we click the Add to Cart button here. That's firing a command down into the view model for this main view, and then that's publishing an event that the shopping cart view model is monitoring. And that shopping cart view model is on every page. You can see that we maintain the navigational backstack here, or really WinRT does that for us. It remembers wherever we went throughout the application there. And then we can go over to the shopping cart here. A couple other experiences that are shown here is that when you select something, you see an app bar pops up at the bottom. So app bars are typically invoked by the user. If you don't know the gestures, a swipe from the top or bottom of the screen on a touch-based device, or the, trying to remember here, I think it's the Window Z key will bring them out if you're using a keyboard. But here you saw it popped out just because I made that selection. So you can do programmatic invocation of your app bars. And it's for scenarios like this where you've got a selection on the screen and you want to show the commands relevant to that individual selection. Another thing we try to demonstrate here is pop-outs or flyouts is another kind of UI metaphor in the Windows Store arena. These things may be complicated enough to have their own backing view models, or they may just be a simple aspect of the page that's showing them. But you can see you can give a rich presentation here to do something like increase the count. And you can see that the main view is updating as those things are changing. Once we go to checkout, now we get into the authentication aspect here. So all throughout that process up to that point, it had pulled down product catalog information, which is publicly exposed over web APIs. But at the point where you start to go to place an order, now it needs to know who you are. So we do authentication over the web services, establish basically a secure session. And we've got a stock user account here for demo purposes. So I'll put that in, submit. And then you can see we get into data entry scenarios. Now, this is not big, heavy, heads-down data entry and data grids type of things. In fact, if you come to another session I'm giving tomorrow at the end of the day, it's going to be a talk on design guidance for line of business applications, where we'll kind of talk about some of these presentational aspects and how you would think about morphing a traditional line of business app that has 400 inputs on the screen and tabs within tabs and data grids in those tabs and scrolling to oblivion and things like that are in so many line of business apps. We'll talk about some of the, how do you shift to the paradigm of a Windows Store app for those scenarios. But we wanted to show some, basic data entry in this application, especially so that we could demonstrate the validation capabilities here. So one of the things we do with the validation is stay out of the way until the user has done something wrong. There's a bunch of required fields on here, and you can figure them out by the little stars next to the label. But we don't, box them red or do anything to them until the user has actually put some incorrect data in. So if I go in here and change something and back it out, now it knows I've changed something, and when I tab off that field, we get kind of a standard presentation similar to what WPF and Silverlight had, that we get a box around the control, and we get an error message nearby to tell the user what is the specific error from the validation rule. And later in the talk, I'll show you how the infrastructure that supports that is. So for now, I'm just going to put in some data to get past all these rules. And I will put in the state that I live in there. And for now, I'm just going to put a bad zip code just to show you another aspect of the validation there. This one probably wants something that looks phone-like. We can check the same as shipping address, put in something somewhat card-like there. And this, I think, validates that we want something looking like a month and a year. Whoops. No, I do not want to sleep. Let's put in something like so. See if it complains about past or current year. And another sort of number there. Okay, so at this point, everything seems to be happy on the form, but once I go and press submit, notice over here, this zip code validation error showed up. So another thing we wanted to demonstrate is, what do you do about things that can't be validated on the client side? The client-side validation is being driven off of data annotations, a standard mechanism in the .NET platform these days. But some things you have to do a server-side lookup to figure out whether they're valid. So this is one of those on the server side. It's got logic that looks up per state what the valid range of zip codes are in the US. And just two different forms of display here. Notice there's the display directly associated with the field in error, but you can see this is one of those big scrolling views that's a common paradigm in Windows Store apps. We're at 1980 by 1020 up here, so we can see both of them at one time. But if you're on a smaller device like a Surface, that field that's in error may be off screen. So you're generally going to want to show more of a validation summary where the input is that triggers the overall validation. So we show it in both places there. So let me just correct that to something that's a valid zip code. If I can even, why does that keep happening? There we go. And submit again. Now we get past that page, get to the final checkout summary here. A couple other things going on here, similar to what I showed before. We've got these, flyouts, and you can enter new data. It can navigate you to a totally separate page, puts it in the navigation stack. You can navigate back to where you were from there. Similar kinds of things with selecting. I think it's mainly just the addresses and payments that have the navigation here. And then finally, when we submit, it always reconfirms for submitting the final order. It's not liking that because my caps lock is on. Oh, another important point here is the Save Credentials box. What that's using is another platform level feature in WinRT called the Password Vault. If you haven't been exposed to that, it's a WinRT thing that you can put things like usernames and passwords in. It's encrypted and it's protected, so you can just read and write through an API. It's stored locally on the client machine, but then it also roams with your Microsoft account. So if they're logged in with a Microsoft account, they go jump to another machine, they log in with the same thing. Their username, password is already there. They won't have to log in again. So I'll go ahead and submit here, and then we just do kind of a final order confirmation. So that's the overall, functionality there. The code for this, because it is an end-to-end sample like this, is a little too detailed to kind of step through all this stuff in here. So I'm going to switch over in a moment and show you just kind of the basics of putting together an app from scratch with Prism, and then we'll look at some of the validation and navigation aspects as well. So let me switch back to slides for a moment. Getting our drink. Okay, so when it comes to starting to structure an app this way, again, a lot of what we did is based around the MVVM pattern. How many people in here have been exposed to MVVM? Most of you, good. Okay, so I'm not going to go into basics of MVVM here. There's a session right after this on the schedule that talks more about it, building an MVVM framework from scratch that will cover some of those fundamentals. But what Prism does is it's already an MVVM framework that you can use, basically. And so it's got some classes that help you out. The first thing is an application-based class that you'll use to replace the default application class. And the reason for this is it wraps up, there's a bunch of boilerplate code that if you start up, do a file new project with the Windows Store application type, there's a bunch of boilerplate code in that application class around the application lifecycle, handling terminates and when you resume, what do you do, and that kind of thing. Most of that stuff we encapsulated down into this class, and we made it so it sets up some common services that make it more friendly to doing MVVM, basically. So it basically initializes a few services I'll touch on, sets up that boilerplate code for the application lifecycle, and gets it ready to be an MVVM app. Then goes away. There we go. Then for your pages, your views, the thing to keep in mind in a Windows Store app, you're going to build out your application in pages, and you navigate from page to page. So your top-level views in doing MVVM are typically going to be pages. And in fact, based on the style guidelines of Windows Store apps, you're generally not going to have deeply nested compositional stuff with MVVM like you might have in WPF or Silverlight. Like I said, in WPF or Silverlight, it was not uncommon to have a main window, and then inside of that, you had a couple of panels. Inside of one of those panels, you might have 10, 20, 30 different views that would plug in there. Inside one of those views would be subviews that were tab views. Inside of each tab was a view. Each of those views may have had subpanels and things in it. So you had these deeply nested hierarchies of child views and view hierarchies. You generally don't want to do that in a Windows Store app. For the style guidelines are to keep things more focused on one thing at a time, to have more open space in the screen and so on. You could do it. There's nothing technically blocking you. But most of the time you're going to start in your pages or your views, and you might not go any deeper than that for most of your application. So then you'll have supporting view models for those. So we have a base class for the page that is able to kind of delegate some of the stuff you would normally do in the page code behind based on the WinRT samples and things. It delegates it off and lets you do those things in your view model. So you basically derive from that, you switch out your base class from what's called layout aware page is what Visual Studio usually pops in there for you. You'll swap that out and become a visual state aware page. The next thing is on the view model side of things. We've got a base class there as well called view model. And you'll generally derive from this because it's got some infrastructure for navigation and state management that we'll touch on. And basically it sets up also the iNotify property change patterns that you're always going to want in your view models. It inherits a bindable base class that takes care of that for you. So you'll generally swap that out. The one other piece of infrastructure we have there in terms of MVVM is a view model locator. And this is a kind of a pattern people set up in doing MVVM as a way to get your view and view model hooked up to one another. There's a lot of different manual ways of going about that and dynamic ways of getting views and view models hooked up. But view model locators just kind of automate the process and say, ultimately, I have a view, and especially in the context of Windows Store applications, because you've got this page-to-page navigation, it's the fact that a page is loading is kind of the trigger point for things happening. So it's more of a view-first kind of approach from the page down. So the view model locator makes it so you have a common piece of infrastructure that says, okay, I know this page is loading. I can figure out what the corresponding view model type is for that page type. I can do that up, and I can set it as the views data context, basically satisfying the structure of MVVM. So the view model locator takes care of all that for us. It's a convention-based thing, so how many people in here have exposure to ASP.NET MVC? good number of you, okay? So all those hands should get the idea of convention over configuration, the idea that you have controller classes that are part of the addressing scheme, but you don't put controller in the address, but it still knows to go find the class that has controller on it. We kind of stole some of those same patterns for the way the view model locator works. If you have a page that's loading up called foo page, let's say, then it's going to go look for a foo page view model. And that's what it's going to assume is the corresponding view model. It's all overridable, so if you have different conventions for the way you want to name things or the way places you want to put them, it's all overridable. But we have some conventions to make it easy out of the box to get started and use it. Okay, so let me switch back over and let's see what this stuff looks like in code. For this one, I'm mainly going to use the Hello World quick start that's part of the code. But let me show you quickly another important little thing to be aware of is if I go to an empty instance of Studio here, if I say File New Project in the Windows Store category, you can see Prism App and Prism App with Unity here. These, unfortunately, are not officially part of the Prism release. They were something that they just kind of ran out of scope on. But one of the team members, David Britch, who wrote all the documentation for Prism, on his own time went and put these templates together. So there's both project templates as a starting point, and there's also add new item templates for adding a view model, and it takes care of all this substitution I mentioned of swapping out the base classes for you and putting them in the right place. So as a starting point here, if I do just a Prism app, this will show the basic structure of getting started with Prism. So the first thing is you're going to have references to the Prism Store Apps library that I mentioned where most of this infrastructure comes from. You can pull that down, and what this does is it uses the NuGet package. So it's out there as a NuGet package. If you just want to treat it as a third-party library that you pull down as a NuGet, that's available for you to do that. What I recommend when you're first getting started with this is pull down the source code and pull it into your solution so that you can actually step debug into the code. It's all open source. You can modify it if you want. You can change all the namespaces, do what you want with it. But especially as a learning tool, it's good to be able to step down into the code and see what it's actually doing. So, but this template actually puts it as just a NuGet reference there. And then the starting point here would be in the app class. Notice the base class that I mentioned in the slides. Let me change the color scheme here. I'm sorry, that's very dark in here. Let me go to change color theme, light. That's better, right? Yes? Okay. So MVVM app base is the base class from Prism that I said you'll want to swap in there. And if you've ever fired up a Windows Store project and looked at the code that's in your app code behind, you already see the difference here, is that there's not all that boilerplate code because it's been encapsulated down into that app base class for you. When you do this, you'll have to also change it in your XAML, and that's part of where these templates come in and make it a lot easier so you don't have to do a bunch of manual substitution there. But you'll have to change out the root element to match that base class. Then the minimum thing you have to do is override this on-launch application as an abstract member in the base class. And the one thing you have to do at a minimum there, you see here, is that you have to navigate to whatever your starting page is. So in Windows Store, there's this concept of a hub or a home page, the first thing that loads up when the user launches the app. This is where you'll make that happen. And if you go look at the boilerplate code that's in there by default, that same thing is happening deeper down in there. You got to weed your way down and find the conditional statement that it's nested down inside. But there's a navigate statement down there against the frame object, which is the thing that ultimately makes navigation happen. Here you see a navigation service. This is part of Prism, and it's the general idea that in MVVM you want abstraction layers, especially for things that your view models are going to depend on. Because your view model code, to the extent possible, you want to keep unit testable. And that means you shouldn't have direct calls in your view model code to things that won't work right in a unit test environment, such as all these WinRT APIs, such as the frame class, page classes, any UI controls, and things like that. So you'll see these abstraction boundaries like this navigation service puts an interface-based wrapper around the frame, basically. It's called frame navigation service is the actual class. Puts an interface-based boundary around that so that you can also have a reference to that in your view models and control navigation from your view model logic. But your initial navigation has to happen up here in the app class as it's starting up and gets that first page loaded. The other thing that's going on down here is that our first view model that we're going to use here is going to take a dependency on that navigation service. So we have a separate override, optional override called onInitialize, and this is where you'll typically set up any singletons that are scoped for the entire application, new those up, set up their dependencies, whatever they need, kind of the base configuration, programmatic configuration for your app will go here. And what this line of code is doing is it's using that view model locator I mentioned, and it's kind of overriding the default convention already. The default convention would be, I'll show you the code in a moment inside the views and view models, but the default convention for the view model locator is it expects to find your views in a subfolder or really a child namespace of the project called views, and it expects to find your view models in a child namespace called view models, and it expects to have this correspondence between the view type name and the view model type name. So if your view is called main page, it expects your view model to be main page plus view model in the type name. So if all we were trying to do is get those two hooked up and the view model didn't have any dependencies, we wouldn't have to do this extra line of code. But you can see that our view model wants to take a reference to that navigation service down in there. So this is called manual dependency injection. How many people in here use a container of some sort? Unity, Meth, something like that? Okay, third or so. Okay, so that's one thing, for people who are exposed to previous Prism, you had to accept the fact that you were going to deal with a container. In this version of Prism for Windows Runtime, we didn't want to force that on people because it is a big learning barrier for a lot of people to deal with dependency injection and containers. So this is basically saying you don't have to use a container here. We provide a hook point here where you can do manual dependency injection if you need it into your individual view models through these register calls, but only if you need it. If you don't need it, then you don't even need this call. Okay, so that's the startup code. Now for the views, they're just standard XAML add new page would be a starting point, but then you'd have to do some base class substitution like I mentioned. You would change out your base class to be this visual state aware base class, and then you have to change it in the XAML as well. If you use the templates here that David Britch put out, and by the way, to find those, quickest way I know at this point is go out to my blog at briannoyes.net. On May 24th, I did a post when he put those out, pointing to, it's actually out here in Visual Studio Gallery somewhere. So you could also go to Visual Studio Gallery and search for Prism for Windows Runtime. So that's where you can get these templates from, and it just comes down as a Vizix file you can install, and it does auto updating and that kind of thing for you. Okay, so the view is just a page other than its base class, but you can see, again, if you've compared to standard Windows Store apps, when you add new pages, there's a whole bunch of code in the code behind, because the whole WinRT paradigm is based around not presuming that you're going to do MVVM, and so they expect you to do everything in the code behind of the page. The thing you have to kind of keep in mind with Windows Store apps that if you're a experienced .NET developer and haven't dealt with unmanaged code in a while or at all, this thing is an unmanaged code class. Its base class page is unmanaged code. The frame class is unmanaged code. So we're living in this weird hybrid world now in Windows Store apps where the APIs we're dealing with are unmanaged code. We've got these managed projections, as they call them, or wrappers around that unmanaged API. So it kind of looks, feels, and smells like a managed API to us, but ultimately they're unmanaged objects. So that's kind of another reason to do this separation of view model from view, is the view is really an unmanaged object at runtime. The view model, if you write it in C# or VB, is pure managed code that, it's a little more predictable and controllable to our minds as .NET developers. So we add our page, and then we want to pay a view model for it. Now, the way this gets hooked up, this is where the view model locator really comes in, is notice this line of code here, where you just say view model locator, auto wire view model equals true. This is an attached property or an attached behavior, if you've heard that terminology. It's basically an attached property that has a chunk of logic when it gets set. And really what that logic is doing is what I described before. It sees that it's being set to true, its default value is false. And it looks and says, okay, on what element am I being set? It assumes that that element is a page. So it will say, okay, what is the type name of that page? It will tack viewModel onto the end of that type name following the convention I talked about. And then it will go try to locate a viewModel of that type name in the viewModel subfolder. As long as it finds it, it will new it up, and it will set it as the data context of the view. So it basically sets up the whole MVVM structure for you automatically based on these conventions. If you don't like that convention, there's several ways to override it, one of which I already showed. Here you can see now we're taking complete control over that and saying, no, I'll figure out what viewModel type I want, I'll new it up, I'll pass whatever parameters I want to it, and I'll just return it from this factory method basically that I'm passing to this register method that sets up a correspondence between main page. So when the viewModel locator sees main page is being loaded, it just goes and says, okay, I have a factory method that will create the appropriate viewModel for that, and I'll just set that as the data context after construction. So it just automates this whole process for us. In the viewModel itself, like I said, you'll derive from viewModel, and then if you are going to actually do any navigation, you'll take that dependency on the navigation service, and then you'll start making calls to it at the appropriate point. So just to show that a little more, let me jump over to the Hello World that has a tiny bit more going on. This one you can see when you start up, it's got some data binding going on. It's got a viewModel offering up a collection of strings there for presentation purposes. It's got a button with a command hooked up to navigate to a separate page. And in this page, it also demonstrates some of the state management that I'll talk about in a moment. So I'll come back to this after I hit a couple more slides. All right. So when you talk about navigation, again, if you want the deep dive on everything to do with navigation in Windows Store apps, come to my session tomorrow. But the idea is you've got this page-to-page navigation that's going to happen. But in an MVVM world, the place that you want the navigation logic to reside is down inside the viewModel. That's where you're going to have command handlers for button clicks like I just showed, surrounding logic that says, is there any dirty data on the page? Should I let the user navigate away? If not, what do I do? Do I call this service to persist? All that kind of logic should be down inside your viewModel, not in page code behind. So you're going to have a page, you're going to have a viewModel that's currently being presented, and some logic in that viewModel is going to decide I need to navigate away. So that navigation service I showed in the demo is really, as I said, a wrapper around the frame class of WinRT. Puts an interface-based boundary around it so that you can mock that for testability. And basically the viewModel now, if it takes that reference in with the dependency injection I just showed, it can go ahead and make those calls against it to say I want to navigate now. Now a couple things happen when that occurs. Ultimately there's going to be another page and its corresponding viewModel that are going to get lit up as the new page. But you've got one page going out of scope here, and by default in WinRT, pages are released, very similar to ASP.NET Lifecycle, if you will, that the page is only alive while it's being presented. So once you navigate away from a page, WinRT is going to release the references to it. Anything it holds on to, such as its viewModel, there's not going to be a reference path to them, and they can be garbage collected if they're managed objects. So one of the first things the frame navigation service does is it calls back to the viewModel that's being departed from. And that's because, picture the AdventureWorks Shopper app I showed you before. I showed that I could click on that shopping cart icon, which is really a view with its own separate viewModel. So there can be some other viewModel can be the one causing navigation to occur, and you're going to leave the containing page when that navigation happens. So the frame navigation service here calls back to the departing viewModel, if you will, giving it a chance to do cleanup. It may need to call a service to persist the data that was on the screen. It may need to release some, unsubscribe from events or things like that to avoid memory leaks. So this is your opportunity to do that, is with this callback. And then ultimately it's going to be the frame that news up the page that's going to be presented next. So it's really just a wrapping mechanism there. And when that page gets newed up, it's going to new up its viewModel, typically through the viewModel locator that I showed. And then finally, because there might be the initialization logic down in that viewModel, the page itself doesn't call down to the viewModel because it's not directly coupled to whether you're doing viewModels or not. So the frame navigation service will call the new view model and say, okay, you're being loaded up, you've been navigated to. So you have a well-defined place to do initialization logic for your view model as it gets loaded. So you can think of the arrow on the left going up and the arrow on the right going up as your unloaded and loaded events in a view. You have those corresponding things happening in your view model. And specifically the way Prism gets this done is the frame navigation service is really looking to the frame that it's containing, looking at what the current page is, trying to cast the current page's data context to an interface called iNavigationAware defined in Prism that defines these methods that are going to be called. So it basically just has a well-defined abstraction there to say if whatever the data context of the view model is an iNavigationAware, then I know how to call it, and I can call these onNavigatedTo and onNavigatedFrom methods on it without being coupled to the types at all. Okay, in terms of state management, there's a bunch of different application lifecycle states, and I'll talk in a little more detail about this at my navigation one tomorrow. But basically, a Windows Store app goes through a series of states. Starts off in a not running state. User launches it, and it's running. It's on the screen. If the user switches away to a different application, they go off to check their Twitter feed or something, as soon as your app goes off screen, it's being suspended. That means all threads are taken away from it, but all of its memory is maintained. So all your objects, the whole object graph, all the references, you know, the buttons, everything is just chunks of memory ultimately on the heap. They're all still there in memory, but they have no execution cycles. If the user switches back to it, then it just starts running again. Basically, it gets threads again. It figures out where the stack pointer was before, and it just resumes running. And there's not even any events that fire in your app when that resumption happens. Now, where things get a little trickier is, first off, the user can naturally close the app. If you weren't aware, in the early betas of Windows Store apps, they initially, at least Microsoft listens to feedback, because initially they didn't have any way to close a Windows Store app. They were like, no, users don't need to worry about that. They'll never need to close an app. They can just suspend it, and we'll worry about killing it if we think it's appropriate. Users didn't like that too much, so they added the Alt F4 to kill the app, or there's a swiping gesture on a touch-based device, swipe from the top of the screen to the bottom of the screen, and that's a close gesture. And you end up in this state of closed by user. Then the user can naturally launch it again from there, and it's like a fresh start of the application. The tricky part is this nasty thing called terminated. How many people in here have built Windows Store apps already? How much do you like termination as a developer? Probably not a whole lot. Terminated is the state that the operating system itself, the platform, WinRT, can decide at any time when you're in a suspended state that it needs the memory that you're consuming as an application for some other app. And all it does is it just takes that memory away. There's no execution in your app. There's no events that fire. There's no chance to do anything about it at the point where it occurs. And you can see there's multiple paths out of suspended state here. So it basically means you have to be pessimistic. You have to assume the worst. If your app is suspended, which there is an event when you are suspended, and that's the one you really care about, it's kind of your equivalent to the closing or closed events in previous UI technologies. So anytime you're suspended, you need to presume the worst and assume that you might be terminated. And the reason this is important is if you go read the Windows style guidelines for WinRT apps, it says that your app, if it gets terminated and the user starts it back up, they should see exactly the same thing on the screen that they saw when they left it, as if they went suspended and resumed. So, if they've gone 10 levels deep in navigation, they've filled in 5 out of 20 fields on the thing, they've scrolled horizontally, they've selected this, all of that state of the application should be restored when they start it back up, even though it was terminated. All the threads were gone, all the memory's gone. It's really a fresh start of the application, but you have to pretend they just swiped away and swiped back. And that gets very difficult to do. So one of the things we did in Prism is tried to make this a lot easier for you and automate some of the process of saving off that state and restoring it for you when you get terminated and you launch the app again. So basically, when you're in an MVVM world, the place where this state, most of that state probably is going to reside is in properties of your view model. You're going to be doing data binding. You're going to do things like the data bind the selected item of a list box or a list view control to some property on your view model. You're going to be populating that list view with a collection from your view model. You're going to be, as you do data input in text fields, those are probably bound to properties on your view model or on the model objects that sit underneath your view model. So all the state that you generally care about, and we're really talking about transient state here. If it's something like the product catalog that you retrieve from a service, obviously every time you start the app, you can go back out and get that data. But it's transient data, which becomes even more important in a business app where there's actual data input. That's the data you really care about here, because if they're heads down filling in some fields and then they go must check Twitter and they swipe away, that's the moment where you are responsible for retaining all that transient state in those text boxes, so that if it gets terminated right then and then they come back to it, all their data is still there and they haven't lost their work. So that stuff is usually in properties of the view model, properties of the model objects, or possibly in caches in some client-side services or repositories. So what Prism gives you is some things where you can just put an attribute on your properties in your view model, and it will automatically check when it gets a suspended event. It's going to write that data out to disk. And when the app launches, if it sees that it's launching from a terminated state, it will read that data back in and push it back into those properties on your view model. And those properties on your view model can be complex objects. So it could be a whole person object with an address object with a street object and so on. It can be a whole object graph that you persist there. If you have data kind of more behind the scenes in something like a repository, some data maybe that you cached, they've been doing some changes to some data and you haven't saved it to the back end yet, then there's a service you can take a dependency on called the session state service with an interface boundary on it. You inject that down into your repository and you read and write through that thing as a dictionary and it will persist its state in a similar fashion. Sorry, I'm just going to make sure I'm unlocked here. So that's the infrastructure there. Let's see what it looks like in the code. So if I go back to my Hello World demo here, we can see, so from a functionality perspective, I think it's still running here. Let me get back to it. Again, we've got some state here in the list box, or list view. We've got navigation, and then we've got transient state opportunity here with text boxes. So as soon as I put some stuff in here, and you can see by the labels there, it's a little small text up there with this resolution, but first one says data retained in a view model. The second one says data retained in a repository. So the two different forms I was talking about there. Where this comes in is if we go back to Visual Studio, there's a toolbar you can bring up called the debug location toolbar. And it's got this little drop down. And poorly named drop down here, this should really say terminate or suspend and terminate, but it says suspend and shutdown. If you select this, it's going through the whole process that I showed in the state diagram. That it first suspends the app, and then it terminates it the same way the operating system would if it was running low on memory while that app was suspended. But you can see that when we start back up now, it goes back to the right page, and all that transient state of the page is retained there for us. Now, the way you do that with Prism, if you don't have Prism, what you have to do is basically go grab those values out of the controls yourself, write them into a dictionary. When the app launches again, you got to check state flags and then go read them out of a dictionary yourself and use this class called the suspension manager that's part of the project. With Prism here, all you do is that data is probably exposed through properties on your view model. So you just put this restorable state attribute on the property on the view model that contains that data. If it is a complex object, you have to go out to your app class. And there is another override that you would put in here called on register known types for serialization. And then there is a class called a service called session state service that you register known type. If you've ever done any WCF, you might recognize that terminology. Just like the suspension manager, the Visual Studio projects you use by default, they're using the data contract serializer of WCF under the covers to do that serialization. So it has to know the type of any object it's going to serialize. This is your hook to be able to tell it about that. So if you have some complex object as a property on your view model, you just come out here and tell it about all the types that are in that object graph through these register calls. Okay, so for view model properties, it's just a matter of restorable state if it's a primitive, plus that registration if it's complex type. For data that's behind the scenes in a repository, for example, what you do is you take a dependency on this iSession state service. So that has to get down in there somehow. If you're using a container, it can automatically inject it. In this case, we're doing the manual dependency injection, these register calls again, for the view models, and then when we construct, where is it here? Navigation service data repository, right here. So you can see when we construct that data repository, we inject that session state service that's already a singleton created by the app class. We inject it down in there so it has access to it. And then all the data repository does is it reads and writes from it basically as a dictionary. You can see there's a session state property that hangs off of that is a dictionary. You have to come up with a unique key for your class or your scope of data that you want to read and write into that thing. And then you just read and write that data through the dictionary. That dictionary is auto-persisted for you on suspension, and it's auto-restored for you if you're launching from termination. So that's the session state management and the navigation. All right, I got 15 minutes left. Let me talk quickly about validation. So validation, as I mentioned, the challenge here is there's nothing built in to help you out at a UI level in WinRT at the current time. Bindings don't have any notion of validation. Controls don't have any notion of what to do about it. So you could go and build your own, and that's basically what we did for you in Prism. But if you were going to approach it that way, you'd have to think about what exactly should that mechanism do for you. So one thing I mentioned when I was doing the AdventureWorks demo is, don't annoy the user before they haven't done anything wrong. Way too many apps out there, partly because of the way the validation mechanisms worked in WPF and Silverlight. As soon as you brought up a screen that had a bunch of required fields, they'd all be boxed red and have error messages on them. That's just cruel to the user. They haven't even had a chance to do anything wrong, and you're just like telling them they've screwed it all up already. So we wanted to make sure that it didn't trigger until they had actually put some input. The trigger in general is when the properties change, when they've actually set something. And we wanted to be able to define the rules in a standardized way. As I mentioned, we use data annotations, which are, if you haven't been exposed to those yet, ASP.NET knows about them natively, Entity Framework knows about them natively, Silverlight and WCF Data Services knew about them. So it's a very standard mechanism in .NET for a declarative approach to validation rules. There's built-in rules for ranges, required, string length, regular expressions, and then there's a way to define your own custom validation methods that you can point to through the attributes. So basically, we use those as the way we will attach our rules to view model or model properties. And then we also needed a way to display those errors on the screen. So what Prism does for this is there are several classes that support this. First off, there's a class called Bindable Validator. We'll see in the demo. This is the thing that evaluates the rules and then maintains a list of errors per property on the object that it's attached to. So it's basically a little helper object that will do all the validation stuff, but it kind of hangs off of some data object itself as sort of the repository of error information associated with that object. Then we've got a class called Validatable Bindable Base, which is a mouthful. If you have done any Windows Store stuff already, you've probably seen Bindable Base. It's a class that gets injected by Visual Studio when you create a project into the common subfolder. And all it's really doing is encapsulating the iNotify property change pattern. This one derives from a variant of that. So Prism has its own copy, if you will, of the bindable base in its namespace. And that's because we have to take this dependency on it. And it's kind of hard to take a dependency on something that doesn't get code generated until you create a project in Visual Studio. So we just took a copy of bindable base, basically put it down in the Prism store apps library so that we could then derive from it to have this validatable bindable base. It basically holds on, like I said, the bindable validator hangs off the side of some data object. So what this does is it does that hanging for you. So it has a contained member that's a bindable validator. And the idea is you'll derive from this for your model objects primarily. And those model objects and their property setters will just call down into the bindable base part. There's a set property method you can call. And that will become the trigger for the bindable validator to do its validation on those properties as they change. Then the one last piece is how to display this stuff on the control itself. For that, we use attached behaviors. How many people in here have used a behavior before? Very few. Okay, maybe about 24 people. So behaviors are a pretty popular thing in WPF and Silverlight. There are blend behaviors that are built into the blend SDK that you can use. There are kind of pre-built ones. Those all kind of came into being because of an approach called attached behaviors that were done in the early days of WPF. And they're basically a way of extending a control without having access to the control source code. They're sort of the XAML equivalent of an extension method in C#, if you've been exposed to those. They're a way to basically tack something on through an attached property, like the view model locator stuff I showed. It makes it so that when that attached property gets set, it can go grab a reference to the object that it's on and do things to it. And so that's exactly what we want to do here is we want to display a red box, for example, around the control that has a validation error. So we put this attached property on there that when it sees a property change happen on that, it goes and gets the errors from a known location, which I'll show in the code. And then if there are errors there, it puts a red box around it, or it puts a star next to it, or whatever presentation you want for that. So let's switch back here. And I'll go over to the validation example. I'll run it first so you can see the basic functionality here. Again, nothing showing an error, but all of these are required fields. As soon as I've changed one of them, then we get the red box as the attached behavior drawn thing. The text itself is actually just straightforward data binding against the collection of errors, and I'll show that in the code. So where you want to put that on the screen, whether you put it right under the control, like I showed in the AdventureWorks, or you put it down below as a validation summary kind of thing, that's just kind of some basic data binding with text elements on the screen. Now, the infrastructure that supports this, if I go down into the code here, you'll see there's a data object, a model object, if you will, in MVVM terms. And it's got 3 properties on it, like you saw on the screen. Each of these has data annotation attributes on it for things like required and regular expression to be able to say what are the rules associated with that property. These look a little more complicated than you may be used to because they're also localized. So they're pulling their error strings out of resources so that they can be localized. But that's all there is from the model object's perspective, other than the fact that it needs to have this validatable bindable base class as its base class. And as soon as it has that, anytime a property change gets triggered, because one of these properties gets set, and its set block calls the base class set property. If you haven't seen that, it's down in the bindable base. And first it's wrapped here in the validatable bindable base, but let's go to the base one. It's basically just wrapping up the standard pattern you would have in a set block with I notify property change, that you need to check whether it actually changed, and then you need to raise the property changed event if it did change. You can collapse all that down to a single line of code here in your set blocks by using this bindable base class. And then the validatable bindable base, you can see, overrides that down here at the bottom, and it uses that as a trigger to do validation. So it's using this bindable validator instance that it contains up here as just a member on the class, and it triggers that and says, okay, some property just changed. This is the property that changed, and it passes that to a validate property method on the bindable validator. Now, I know I'm going through this all very fast. This is more intended to get you an overview of what's down there and what it can do for you. You know, definitely go back and pull down this code, try it out, and dig down into exactly what all these things are doing for you. But you can see it's a fairly simple mechanism. Just put your data annotation attributes derived from validatable bindable base, and magic happens and the validation will occur. Then you need to display it. So let me show you quickly what one of those behaviors looks like. It's basically first and foremost an attached property. So it's a dependency property with a register attached call. And in this case, it's called property errors is what we're going to set in the XAML. And when it gets set down here, you can see what it's doing is it's looking at the value that it's being set to. So it expects you to point this through a binding to an errors collection associated with the control. And if there's something in that errors collection, then it's going to go ahead and do something visible to that control. And you can see the way we do it here so that we're not locking it down to always being a red box is we just say, go grab a well-known named style that should be in the application scope and apply that to the control when there are errors. And if there's not errors, then take it off. And so where this gets hooked up in the XAML, real quick, you can see here on the text box, we just got that highlight on errors.property errors being set to a binding that points to the errors collection. So this errors collection comes off of that validatable bindable base class. It's maintaining per property a list of errors that were triggered by those validation rules. And you can just bind to it through this to get the red box or whatever style you put into that name style. And then down below, the text display of what errors that are there is just, like I said, some straightforward text block data binding here against that same errors collection. In this case, we're using a binding at the text block level for a single string, and then we're calling a property on the base class called all errors that kind of flattens across all the properties, all the errors associated with those properties. Okay, now if you go look at the code for the AdventureWorks shopper, it does it a little bit differently. If I can find that real quick. Running a little low on time, but let me see if I can find it real quick. Here in our, let's say, billing address page, if you remember, the display in that case was on a per property basis instead of just a summary. So somewhere, that's not the view I wanted. Billing address user control is the one I wanted. So down here, let's find one of our text boxes. Form field text box here. So you can see that here we've got the same property errors behavior pointing to the errors collection. And then we have a separate text block to display the error right in line there. And this one can bind to the .errors passing in the name of the property so that it gets just the set of strings associated with that one property, similar to the binding up above for the boxing part of it. Okay, so that's the validation mechanisms of Prism. And it kind of builds entirely, from scratch because WinRT currently doesn't have anything to support you there. So with that, let me switch back to the slides and kind of wrap up here. So there's a lot more there. I went through this, very fast because there's a lot there to cover. But there's even more in Prism that you can check out and benefit from. There's guidance around working with web APIs, calling web APIs, doing security with forms authentication, doing things like managing the cookies that come back in the face of termination, writing those into that restorable state stuff that I talked about. There's guidance around doing CRUD and RPC calls, like I said, security, I already said all this stuff. Oh, and the server validation that I mentioned with doing server-side lookups, but still re-affiliating it with that client-side validation that I just showed. We show working with the search charm, the settings charm, doing flyout panels for the settings panels in particular, doing live tiles and secondary live tiles, where you can have basically a deep link on the desktop or on the start screen that goes directly to a particular page and view model within your application. We show some client-side caching of the product catalog after you retrieve it. You don't want to re-retrieve it every time because it probably doesn't change that often. So we show how to do that into local storage and check whether it's there and go ahead and load it back up from there or call the service. And also the credential management using that password vault and wrapping that to read and write your username and password so it roams, as I said, across multiple machines. So a couple of resources for this, like I said, come up afterwards. I'll have a stack of these cards for the Pluralsight things. That's the course up there on Prism. And I've also got an article series on the Silverlight show site. Just go to tinyurl, Prism RT series, and I've got, I think there's 5 or 6 parts in it so far. I've got one more part to write before that series is done. And I'll be doing that by the end of the week. All right. And then the one other resource I mentioned is for those templates for Visual Studio. Just go to my blog, May 24th, and you will see the post that points you to where to get those templates. With that, thank you for your attention. Please do fill out evals. I'll get the QR code up here. Fill out your evals. Enjoy the rest of the conference, and feel free to come up and ask any questions. I'll answer those with the remaining time. So thanks a lot.